value of this function at x is equal to 2. So from the graph we can say that, or from the definition we can say that for the x is equal to 2 this function is not defined, because at x is equal to 2 denominator becomes 0. ઓકે, સો કહેવાનો મતલબ એ છે કે આ ફંક્શન છે એ x ઇઝ ઇક્વલ ટુ 2 માટે ડિફાઇન્ડ નથી, તો આપણે x ઇઝ ઇક્વલ ટુ માટે આ ફંક્શનનો આન્સર મેળવી શકીએ નહીં. તો આવા કેસની અંદર લિમિટનો આઈડિયા જનરેટ થાય છે કે if we take x is equal to 2 then the denominator becomes 0, but if we take the value of x nearer to x but not equal to x, then denominator nearer to 0 but that is not equal to 0, so we can do that. We can take the value nearer to x, and that is the idea of limit generates. Okay, what happens at x is equal to 2? What is f of 2? And what happens near x is equal to 2? So when the value of x approaches to 2, then value of f of x approaches to -3. That means when the value of x is nearer to 2, then the value of f of x is nearer to -3. Okay, so this is, so question is what happens as x approaches to 2? As x approaches to 2, the function f of x approaches to -3, or in other way we can say that when limit x tends to 2, f of x is equal to -3. This is the understanding of the limit. In the same way we can say for this function as well. Okay, at x is equal to 1 function is not defined, but what happens near to x is equal to 1? We can say that as x approaches to 1, g increases without bound. That means g approaches to infinite. As x approaches to 1, g approaches to infinite. As, okay, x increases without bound, then g approaches to 0 in inverse way. Okay, so this is the, we can say that in this case as x approaches to infinite, g approaches to 0, or in other way we can say that as x approaches to 1, g approaches to infinite. Okay, so what can we say from these two type of examples? From this example we can say something about the limit. What is the idea of the limit? So if we start with a number c and a function f defined at all numbers x nearer to c but not necessarily at c itself, in any case whether or not f is defined at c, okay, how is totally irrelevant. Okay, now let L be some real number. We can say that the limit of f of x as x tends to c, or roughly speaking we can say that the limit of f of x as x approaches to c is equal to L, and we can write it limit x tends to c f of x is equal to L, and roughly speaking as x approaches to c f of x approaches to L. Okay, so here f of x is close to L for all x is not equal to c. When we write limit x tends to c, that means x is not equal to c but x is close to c, not equal to c, x is close to c. Okay, so this is the definition, formal definition of the limit. Let c and L be real numbers. The function f has limit L as x approaches to c given any positive number epsilon there is a positive number delta such that for all x 0 less than mod x minus c less than delta implies mod of fx minus l less than epsilon, then we can say that limit x tends to c f of x is equal to L. This is the mathematically definition of limit. Okay, that means as x approaches to c, f of x is approaches to L, or in more standard language we can say that limit x tends to c, f of x is equal to L. So this is the definition of limits. The sentence limit x tends to c, f of x is equal to L is read like this one. I have mentioned the limit of f of x as x approaches to c equals to L, right? So don't mistake to read this statement. Okay, you need to read in this way: limit of f of x as x approaches to c is equal to L. The notations means that the value of x approaches but does not equal to c. The next figures illustrate the fact that the existence of limit as x tends to c never depends on how the function may not be defined at c. Okay, so this is something more about the definition of the function. This idea represents the same thing about the definition of limit. Okay, the function f has a limit 2 as x tends to 1 in the first figure. The function g has a limit 2 as x tends to 1 even though g of 1 is not equal to 2, and the function h is the only one whose limit as x tends to 1 equals its value at x is equal to 1. Both are equal. Okay, so this is the something more about the limit. This is fundamental laws of limit. Limit x tends to a, f of x plus g of x is equal to limit x tends to a, f of x plus limit x tends to a, g of x. Second one, limit x tends to a, f of x minus g of x is equal to limit x tends to a, f of x minus limit x tends to a, g of x. Same way, limit x tends to a, c into f of x is equal to c limit x tends to a, f of x. In the same way for the multiplication, same way for the division. These are the basic laws of limit. Verbally, these laws can be stated as follows: the limit of sum is the sum of the limit. That means we can give the separate limit for the addition. Okay, that is the limit of the sum is the sum of the limit. Limit of the difference is the difference of the limit. For the difference, limit x tends to a, f of x minus g of x is equal to limit x tends to a, f of x minus limit x tends to a, g of x. Same way, the limit of a constant times any function is the constant times the limit of the function. That means we can remove the constant outside the limit, because limit always for the here limit is for the x, so c have no meaning with the limit, so we can put c outside the limit. So constant times a function is the constant times the limit of the function. That is our third property. And limit of the product is equal to product of the limit for the multiplication. That means we give the separate limit to the product of any two functions. And same, the limit of a quotient is the quotient of the limit, but here one condition we have to check: did if which function is in the denominator. If the limit of the denominator function is equal to 0, then we cannot do that. So because we can say limit x tends to a, f of x upon g of x is equal to limit x tends to a f of x upon limit x tends to a g of x if limit x tends to a g of x is not equal to 0. જો છેદમાં જે ફંક્શન હોય એની લિમિટ ઇક્વલ ટુ 0 થઈ જાય તો આ વસ્તુ પોસિબલ નથી. એટલે કે જો છેદમાં જે ફંક્શન હોય એની લિમિટ નોટ ઇક્વલ ટુ 0 થતો હોય તો જ આપણે ક્વોશન્ટ લો એપ્લાય કરી શકીએ, બાકી આપણે લો એપ્લાય કરી શકીએ નહીં. તો આ જે મેઇન રૂલ હતા એ એડિશન માટે, સબટ્રેક્શન માટે, મલ્ટિપ્લિકેશન માટે, ડિવિઝન માટે અને એની ઉપરના આપણે એક્ઝામ્પલ પણ સોલ્વ કરી શકીએ. એક્ઝામ્પલ based on these limit laws. So if we look at the PPT, then the simple example based on properties of limit. So question is use any properties of limit to find limit x tends to c 5x raised to 4 minus 13x plus 2. So first we will use the sum and difference rule. So here limit x tends to c 5x raised to 4, then minus limit x tends to c 13x, then plus limit x tends to c 2. Then product and multiple rules. So this is equal to 5 as constant, we can remove it outside, and x tends to c, so we can put x is equal to c, so that is equal to 5c raised to 4 minus 13c plus 2, because x tends to c doesn't make any difference to 2. So answer will be 5c raised to 4 minus 13c plus 2. The same second example. So first we will use the quotient rule. Here is equal to limit x tends to c x cube minus 4x upon limit x tends to c x square plus 8. Then we will use the sum and difference formula. So limit x tends to c x cube minus limit x tends to c 4x upon limit x tends to c x square plus limit x tends to c 8. So we will get, then the product and multiple rules, we will get c cube minus 4c upon c square plus 8. So these are the example directly based on the rules, or we can say the properties of limit. So in this way we can use the properties of limit. I am giving more time on this rule because these are most important rules for the next portion of this chapter, when we are going to solve the special kind of examples, mainly based on factors, example with the infinite limit, then the other example for the trigonometric functions. These properties are always useful for us to solve that kind of examples. So these are the examples. These examples is very useful for us to understand the next portion. So in next session we will discuss the main specific example of limit using the some special formulas of limit. So that's it for today. In the next session we will discuss that specific formula of limit. So that's it for today. Thank you very much.